In this video, I'm going to show you capital budgeting, the very basics of capital budgeting. The good news is that you already know everything you need to know to run these problems. You're just going to learn a new application. And what I mean is, we are going to use all the techniques we learned in time value of money and in the valuation of stocks. That's basically what we're going to do. Yet this is the application. We're going to apply it to the corporate world. We're going to apply it to a project. So instead of applying the concept of time value of money to securities, we're going to apply it to an actual project. What kind of project? Any type of project. You could be looking at building a new factory, expanding an existing factory, opening a new store, new products. Anything you can think of can be evaluated using this method. So I'm using the problem from the slides. And in this case, we have a project where we start by laying out all the different components. So we have a initial outflow of cash of $100. That's why it's negative, because it's an outflow. So we have $100 outflow on time zero right now. What does this mean? Well, it means that we assume that in any type of project, you need to come up with a certain amount of money right at the beginning, right? You need to build a factory, so you need to buy that factory. You need to you want to open a new store, so you need to pay for rent or whatever it is. We're going to assume you're going to pay it at the very beginning. Okay, negative 100. Then, as time goes by, we're going to assume, and we'll talk more about that in the next chapter. We're going to assume that these are the positive cash flows of your project. So in the first year, you're going to make 10. The second year, you're going to make 60. And the last year, you're going to make 80. Okay? So right now, you're going to pay $100 to get 10, 60, and 80, right? 10 in a year, 60 in 2 years, and 80 in 3 years. These are not payments, so it's not 10, 10, 10, and 60, 60, and 80. This is 10 on the first year, 60 on the second year, and 80 on the last year. It's not an annuity. It's not equal payments across. None of that. Okay, so you see what we have here? We have a timeline. Okay, so this should look to you this is identical to stock valuation, right? So what do you think is the value of any project? As I have told you before, the value of anything is just the present value of the individual payments discounted to today. And that's what we're going to do. So the value of this is going to be the present value of negative 100, the present value of 10, the present value of 60, and the present value of 80. Sorry. Meaning we are going to discount each of them to today. So you could do it, and you should do it the first time, right? You should do it like this, right? So what's the present value of 10? It will be 10. Oh, I'm sorry, I forgot to tell you about the rate. So what is the rate that we're going to use? Well, we have calculated that the WACC for this project is 10%, and we'll talk more about that. In this chapter, I'm going to give you WACC every single time. I may actually to compute one or two, but they won't be that complicated. It's everything that you did in the previous chapter. But we'll talk more about where WACC comes from, what affects WACC and how WACC can go up or down, okay? So it's going to be 10%. So the present value of the first payment of $10 will be 10 divided by 1 plus 0.10 raised to the first power. The present value of 60 will be 1 plus 0.1 raised to the second power. And finally, the $80 would be 80 divided by 1 plus 0.1 to the third power. So you would take those three values and the negative 100, right? You add them all, and that will give you what we call the net present value of this project. Okay, so you just find the present value of all of them. That gives you the net present value. Now, Excel can make things a lot easier for us. I'm gonna scroll down a little bit. All right, here. All right. So let me rewrite it now. I'm going to write it in Excel. 10, 60, 80, with WACC being 10%. To find the net present value of this, which is identical to the one above, right? What you're going to do is you're going to use the NPV formula in Excel, right? What is the rate? The rate is the WACC, 0.10, comma. What are the values? Now, this is where it gets tricky, and you need to pay attention to what I'm about to do. I absolutely can. I cannot understand what the Excel programmers were thinking when they did this. This is wrong. This is not how I would have done it. But it is the way they did it, so we have to go along with it. You now need to select the values, but you are not going to select the negative 100. Why? Because the negative 100 happens at time 0. If you include negative 100 as part of the NPV formula, Excel thinks that the first value in the array happens at the end of the first period, and that is not true. It happens at the very beginning, today, right now. So you need to exclude 100. You do not select it. So look, you only select the 3 payments that happen in years 1, 2, and 3. Okay? Now you're going to close the parentheses. Now you're not done, because notice the negative 100 is nowhere in this calculation. So what you're going to do is, once you close the parentheses, after doing the NPV formula, once you close the parentheses, you're going to subtract, you're going to deduct the initial outlay of cash. See what I did? Negative 100. Enter. 1878. That's the NPV of this project. So imagine you are running, so let's call this project A. That's project A, and let's say that we have project B. And let's say that project B is identical to this one, but the first year you get 20, and the first year, in the second year you get 50. Okay, I just changed the numbers a little bit there, right? So let's find the NPV of this new project. Right? The rate is the same, comma, these are the new payments, close the parentheses, minus the initial outlay of cash, 1961. Now, these two projects, they look similar. The only difference is the payment on the first year and the second year. So the first year payment went up by 10, the second year payment went down by 10, and yet look what happens. Project B now has a higher net present value than project A. So project B is better than project A. It gives us a higher return. So if this is a case where these are mutually exclusive, meaning if we do one, we cannot do the other. So for example, imagine this is a situation where you are going to build a factory and you're wondering if you should build a factory in California or in North Carolina. And you do the math, and these are the numbers. The one in North Carolina has a net present value of 1961 versus 1878 for California. In this case, if they're mutually exclusive, if you can only pick one, you would pick project B with the higher NPV. That's the very basics of NPV in capital budgeting.